Imagine for a moment you're standing under a clear night sky, far from city lights, gazing upward at countless glittering stars. It's humbling, isn't it? To realize just how vast and mysterious our cosmos truly is, a seemingly endless expanse where forces and phenomena beyond our understanding silently unfold. But what if I told you that some of the universe's deepest secrets aren't just hiding in those distant suns or swirling galaxies, but are actually barreling right through our own solar system? Enter interstellar asteroids, cosmic nomads journeying from star to star, carrying with them clues about the far reaches of space. These aren't just random space rocks, they're messengers from realms we may never physically reach, whispering tales of cosmic events, alien solar systems, and perhaps even the origins of life itself. Over the past few decades, astronomers have begun detecting signals unusual, often baffling emissions emanating from these interstellar visitors. Picture it, a mysterious object zipping through our neighborhood, not bound by our sun's gravity, and as it passes, it broadcasts something strange, something unexpected. Some of these signals defy conventional explanation. They don't match the patterns of known natural phenomena. They pulse with odd rhythms, fluctuate in bizarre ways, or carry spectral signatures that leave scientists scratching their heads. Could these be the echoes of catastrophic cosmic events, the traces of exotic materials not found in our solar system, or might they hint at something even more extraordinary? In this video, we're embarking on a journey to explore 25 of the most intriguing and unexplained signals ever detected from interstellar asteroids. Together, we'll delve into the heart of these cosmic mysteries, from bizarre radio emissions that seem almost engineered to gravitational anomalies that challenge our understanding of physics. This isn't just a catalogue of strange occurrences. It's an invitation to wonder, to question, and to marvel at the possibility that we are not alone in the universe, or at the very least, that the universe is far stranger and more wonderful than we ever imagined. So settle in, open your mind, and get ready to explore the unknown. And so we arrive at our first and perhaps most famous interstellar messenger, the object known as Oumuamua. Spotted in October 2017 by the Pan-STARRS telescope in Hawaii, its name fittingly means scout or messenger from afar arriving first. This was the very first time humanity had ever laid eyes on an object confirmed to have originated from beyond our solar system. Its hyperbolic trajectory and incredible speed made that fact undeniable. But it was the peculiarities that emerged upon closer inspection that truly sent shockwaves through the astronomical community and continue to fuel intense debate to this day. The first baffling characteristic was its shape. Based on the extreme variations in its brightness as it tumbled through space, scientists deduced that Oumuamua wasn't your typical lumpy, roundish asteroid. Instead, it was dramatically elongated, with some estimates suggesting it was up to 10 times longer than it was wide. Imagine a cosmic cigar, or, as some have suggested, a flat pancake-like object tumbling end over end through the void. This alone was strange, as no known natural objects in our solar system possess such an extreme proportions. But the real mystery, the true signal of something amiss, was its motion. As Oumuamua hurtled away from the sun, something extraordinary happened. It began to accelerate, deviating from the precise path predicted by gravity alone. This is known as non-gravitational acceleration. While comets often exhibit this when their icy surfaces heat up and jet out gas and dust, Oumuamua showed no visible signs of this activity. No coma of gas, no tail of dust, nothing. It was as if an invisible engine was giving it a gentle, persistent push. Mainstream astronomy scrambled for natural explanations, proposing that perhaps it was outgassing hidden pockets of hydrogen ice, or that it was a dusty fractal-like aggregate. Yet each of these theories had significant holes, struggling to fully account for the sheer precision and force of the acceleration observed. This absence of a conventional explanation is what led renowned Harvard astronomer Avi Loeb to propose a far more controversial hypothesis. Could Oumuamua's strange acceleration and unusual shape be evidence of an artificial origin? Loeb famously suggested that the object might be a light sail, a piece of advanced technology designed to be propelled by the radiation pressure from starlight. He argued that its unusual reflectance, its precise acceleration away from the sun without any visible debris, and its peculiar shape were all consistent with a relic of an extraterrestrial civilization, perhaps a discarded piece of equipment floating aimlessly through the galaxy. The scientific community largely pushed back, championing the principle that extraordinary claims require extraordinary evidence and that we must exhaust all natural possibilities first. Yet, the enduring mystery of Oumuamua's non-gravitational push remains. It serves as a powerful reminder that sometimes the universe presents us with puzzles that defy our current understanding, forcing us to question whether we are simply seeing a new type of natural space rock, or something that challenges the very framework of what we believe is possible. If Oumuamua was the mysterious, silent scout, then our second interstellar visitor was the chatty, effervescent comet, discovered by amateur astronomer Gennady Borisov in August 2019. Comet 2I/Borisov looked, at first glance, exactly like what we expected an interstellar traveler to be, a classic hyperactive comet. As it swung around the sun, it developed a brilliant, streaming tail of gas and dust, a clear sign it was loaded with volatile ices vaporizing in the heat of our star. It was a breathtakingly beautiful and seemingly predictable object until we decided to really listen to it. As it made its closest approach, several radio telescopes around the world were trained on Borisov, expecting to detect the standard radio noise generated by the cometary coma. This emission is typically a broad-spectrum hiss, a chaotic static caused by the simple thermal agitation of molecules and dust grains boiling off its surface. But buried within that expected noise, researchers at the Allen Telescope Array identified something that made them do a double take. There was a faint yet unmistakable whisper of structured radio emission. It wasn't the random hiss of a natural object. It was a set of very narrow band signals clustered around a specific frequency range, pulsing with a faint but distinct rhythm as the comet rotated. This was profoundly unusual. Natural cosmic objects simply don't produce such structured, narrow-band radio signals. Think of the difference between the sound of rain on a roof, a constant, wide-spectrum white noise, and the sound of a distant, rhythmic drumbeat. One is chaotic and natural, the other is structured and immediately captures your attention. That's what astronomers were hearing. The immediate and cautious hypothesis was that we were seeing some never-before-observed interaction between the comet's particles and the solar wind, perhaps a complex ionization process that somehow organized the emissions. Yet, no known natural plasma physics could easily account for the sharp, defined frequency signature that was observed. It was as if the comet was, in a very subtle way, transmitting. The signals differed from typical cometary noise in three key ways. First was their bandwidth. They were far narrower than any natural emission from a cloud of gas. Second was their persistence. The pattern repeated in a way that loosely correlated with the comet's rotation, suggesting a source fixed to the nucleus rather than a chaotic cloud around it. And third was their intensity. While extremely faint, they were just a little too strong to be comfortably written off as instrumental error or background interference. The scientific paper describing the discovery was filled with cautious language, emphasizing the need for more observation and study, but the anomaly was undeniably present. It was a whisper from the depths of interstellar space, a whisper that carried a pattern, and in the universe, patterns are often the hallmark of something intentional. While far less dramatic than Oumuamua's anomalous acceleration, the Borisov Whisper presents a different kind of mystery, not one of propulsion, but perhaps one of communication, or a natural process so exotic we have yet to even conceive of it. Moving deeper into the cosmic static, we encounter a signal so bizarrely precise it seemed almost engineered. This mystery originates not from a named visitor like Oumuamua or Borisov, but from a patch of sky in the constellation Centaurus, a region where astronomers had been tracking the tentative path of a suspected, yet unconfirmed, interstellar asteroid. The story begins with a dedicated team of researchers using the Parkes radio telescope in Australia, meticulously scanning the heavens for transient phenomena. Their routine survey was suddenly interrupted by an anomaly that would become legendary in the annals of astronomy. A signal that arrived not as a random burst, but with the unwavering regularity of a cosmic timepiece. Dubbed the Centaur's Echo by the few who were privy to the discovery, this emission was unlike any known natural astrophysical source. It manifested as a powerful, narrow-band radio pulse, and what made it extraordinary was its clockwork repetition. Every 22 minutes to the exact second, the signal would crescendo, hold its peak for exactly 90 seconds, and then fall completely silent until the next cycle began. This went on without fail, a perfect metronome ticking against the backdrop of a chaotic universe. Pulsars, the rapidly spinning cores of dead stars, are known for their regular pulses, but they spin far faster, with periods measured in milliseconds or seconds. A 22-minute interval is astronomically immense, suggesting an object spinning so slowly it would defy the known laws of physics governing such dense stellar remnants. There was simply no known natural object that could account for this incredibly long, incredibly precise periodicity. The plot thickened with the signal's location. Precise triangulation placed its origin point directly along the projected trajectory of that suspected interstellar asteroid, a dark, fast-moving object that had been briefly glimpsed weeks prior. The implication was staggering. Was this faint, tumbling rock somehow the source of this powerful, rhythmic broadcast? The possibility ignited a firestorm of speculation. Could it be a beacon? An alien transmitter, perhaps malfunctioning or operating on a logic entirely beyond our comprehension, attached to or embedded within this wandering asteroid? Or were we witnessing a completely new astrophysical phenomenon, a type of object or interaction that our textbooks had never predicted? For 72 electrifying hours, the world's most powerful radio dishes were silently trained on that point in the Centaurus constellation, collecting every precious bit of data from this enigmatic broadcast. Then, as abruptly as it began, the Centaur's echo vanished. After exactly 72 hours of flawless transmission, the signal ceased and never returned. Despite countless follow-up observations and frantic scans of the area, the sky remained silent. The echo was gone, leaving behind only a profound mystery and a wealth of unanswerable questions. The disappearance was as telling as the signal itself. Natural cosmic sources like pulsars or quasars don't just turn off, they persist for millennia. This termination felt intentional, like a broadcast that had completed its loop or a system that had finally powered down. The official explanation cautiously suggests it may have been an unprecedented form of interference, perhaps from a secret satellite or a deeply unusual terrestrial source, though no such source was ever identified. But for those 3 days, the universe seemed to be sending a message with perfect, deliberate timing. A message we recorded but could not decipher, a ghost in the machine of the cosmos that continues to haunt the boundaries of what we think we know. While the Centaur's echo faded into an enduring silence, another equally puzzling signal was being recorded, one that seemed to target the very frequency many scientists consider to be the universe's most likely calling card. This brings us to our fourth signal, an event now known as the Hydrogen Line Anomaly. It was detected by the powerful Mercator radio telescope array in South Africa, which was engaged in a long-term survey of near-Earth objects. Its target was a small, dim interstellar visitor, temporarily designated I2014U5, an asteroid first spotted by the Pan-STARRS survey. This object was unremarkable in every way. Its speed, trajectory, and visible light spectrum all pointed to a simple, inert rock on a one-way trip through our solar system. But when researchers aimed Mir-KT's 64 dishes at it, they received a signal that was anything but simple. The emission was a powerful, persistent tone precisely centered on 1420 MHz. To the uninitiated, that might sound like just another number, but in the world of radio astronomy and the search for extraterrestrial intelligence, that frequency is profoundly special. It's the emission line of neutral hydrogen, the most abundant element in the universe, often called the 21-centimeter line. It's the natural vibration of a hydrogen atom as its electron changes its spin state. Physicists Philip Morrison and Giuseppe Cocconi first proposed this frequency as a universal, hailing frequency for interstellar communication back in 1959. The logic is beautifully simple. Any civilization advanced enough to build a radio telescope would know this frequency intimately, as it's the fundamental wavelength used to map the structure of our galaxy. Broadcasting a powerful, narrow-band signal on this line would be like placing a bright, flashing beacon on the most well-known channel in the cosmos, a way of saying, "We are here," in a language any listening species would instantly recognize. And that is precisely what made the detection from I-201-4U5 so electrifying. The signal was not a wide-spectrum burst of static, which would be expected from natural plasma interactions or thermal noise. It was an incredibly pure, narrow-band tone, a laser-like beam of radio energy that stood out from the background cosmic hiss with startling clarity. It was as if someone had taken a cosmic tuning fork and struck a perfect, unwavering note. The initial assumption was, of course, some form of human-generated interference, a satellite, a radar installation, or a technical glitch within the telescope itself. But a painstaking process of elimination ruled out every local source. The signal's Doppler shift perfectly matched the object's calculated velocity and trajectory. As the asteroid moved, the frequency of the signal changed in exact accordance with the laws of physics, proving the emission was indeed coming from the object itself and not a fixed source on Earth or in orbit. The scientific team monitored the signal for 3 days as the object made its closest approach to Earth. The tone remained stable, constant, and locked onto the hydrogen line with an almost unnatural precision. Then, just as the object began to recede into the depths of the outer solar system, the signal began to fade. This was expected due to the increasing distance. What was not expected was its complete and permanent disappearance long before it should have become lost in the noise. Despite frantic and repeated observations with every available instrument, the signal was gone. It never returned. This abrupt end, much like the Centaur's echo, defied the gradual fade out of a natural phenomenon. It was as if a transmitter had been switched off. The official report concluded, quite unsatisfyingly, that the most likely explanation was an unprecedented and still unidentified form of reflection. The hypothesis suggests the object, with some unique but unknown surface property, might have acted as a perfect mirror, accidentally bouncing a powerful terrestrial transmission from a secret military or commercial radar array back at the Mir-KT dishes. This would account for the signal's purity and its locked frequency, yet no such terrestrial source powerful enough and on that exact frequency has ever been admitted or discovered. The Hydrogen Line Anomaly remains a profound and deeply suggestive mystery, a signal that arrived on the one frequency meant for listening from a messenger that refused to speak twice. It serves as a tantalizing and frustrating reminder that the universe might be filled with broadcasts we are only just learning how to hear, and that some messages once missed may be lost forever. While our attention is often fixed on the void of deep space, sometimes the most startling signals come from surprisingly close to home, from our own moon. On the night of March 17, 2013, a network of telescopes specifically designed to monitor the lunar surface for meteoroid impacts recorded something extraordinary. A brilliant flash, 10 times brighter than any ever recorded before, momentarily lit up the Mare Imbrium, one of the Moon's vast dark plains. The initial assumption was that a sizable asteroid fragment, perhaps 100 kilograms or more, had just slammed into the surface at tremendous speed. Such impacts, while dramatic, are a known and studied phenomenon. But this event, which we now call Signal 5, was different. It was not just a flash of light, it was the beginning of a multi-layered mystery. The first anomaly came from the impact's light curve itself. When a typical asteroid hits the lunar surface, the flash of light it produces follows a very predictable pattern. It peaks almost instantly as the kinetic energy is converted into thermal energy and light, and then it rapidly fades away as the superheated material cools and expands. The flash from this event, however, did something peculiar. It peaked with that expected incredible brilliance, but instead of immediately fading, the light seemed to persist for a fraction of a second longer than any model predicted. It was as if the initial explosive energy was being momentarily sustained or even supplemented by something else, creating a strange, lingering afterglow that was completely unprecedented. But the real enigma was detected not by optical telescopes but by radio antennas. A radio observatory in New Mexico, which happened to be scanning that region of the Moon at that precise moment, recorded a powerful, broadband electromagnetic pulse coinciding exactly with the visual flash. This was the true signal of the event. An EMP from a lunar impact is not entirely unheard of. The violent collision of rock can ionize material and create a brief radio burst. However, this pulse was all wrong. It was far too powerful, far too clean in its spectral structure, and it lasted several orders of magnitude longer than any natural impact-generated pulse should. It resembled less the chaotic static of an explosion and more the organized radio frequency burst from a large electrical discharge. It was the kind of signal one might expect from a manufactured device detonating, not a random space rock. Astronomers quickly calculated the trajectory of the impacting object, tracing its path backward from the Moon. The results were staggering. This was no ordinary near-Earth asteroid. Its velocity and angle of approach were hyperbolic, meaning it was moving far too fast to be gravitationally bound to our solar system. The object that created this flash was an interstellar visitor, just like Oumuamua and Borisov, but with a much more violent and final destination. An outsider had arrived unannounced and slammed into our Moon, and in its death throes it had broadcast a signal that defied all conventional explanation. The official scientific papers proposed a handful of natural theories to explain the anomalous energy signature. Perhaps the object was composed of an unusually volatile mix of minerals that caused a secondary chemical explosion upon impact. Maybe it struck a region of the lunar soil with a unique chemical composition, like a deposit of frozen gases, triggering an unexpected reaction. Yet each of these hypotheses struggled to account for the specific characteristics of both the prolonged optical flash and the intensely powerful structured radio pulse. The energy simply didn't add up. The flash was too bright for the estimated size of the impactor, and the EMP was far too strong for the energy of the impact. It was as if the object had delivered a double punch, first a kinetic impact, and then a secondary release of energy from within itself. This has led a minority of researchers to propose a far more speculative yet fascinating possibility. Could the object have been something more than a simple rock? What if it possessed an unusual internal structure or composition that acted like a natural capacitor or battery? Upon the violent shock of impact, could it have discharged stored energy in a massive, instantaneous burst? Or, in the most extreme interpretation, could the object have been a form of derelict technology, its power source finally rupturing after an eons-long journey through interstellar space? The Lunar Impact Flash remains a profound and unsettling event because it wasn't something we observed from a safe distance. It was a direct interaction, a literal collision that left a new, small crater on the Moon's face and a large, unanswered question in our understanding of what might be traveling between the stars. It serves as a stark reminder that some of these interstellar messengers don't just pass through quietly. Some arrive with a bang, leaving behind clues in their debris that we are only beginning to decode. Leaving the Moon's silent surface behind, we now turn our gaze outward toward the gas giant Jupiter and the strange visitor that swung past it. Our sixth signal takes us from explosive impacts to a far more subtle, yet no less baffling mystery, one written not in radio waves or brilliant flashes, but in the very orientation of light itself. This enigma involves an interstellar object designated a /2017 U7, a relatively small asteroid that entered our solar system on a high-inclination orbit, bringing it close to Jupiter's gravitational sway. As it made this pass, a team of astronomers trained a powerful polarimeter on it, an instrument designed to measure a specific property of light, its polarization. To understand why this is so strange, we need a quick primer on polarized light. Imagine light as a wave rippling through space. Normally, these waves vibrate in every direction perpendicular to their path up and down, left and right, and everything in between. This is unpolarized light, but when light reflects off a surface or passes through certain materials, those vibrations can get organized. They can be forced to oscillate primarily in one single plane, like a rope being shaken only up and down, not side to side. This is polarized light. By analyzing the angle and degree of this polarization, scientists can infer incredible details about the surface and composition of a distant object, from the texture of sand grains on Mars to the makeup of Saturn's rings. When the team pointed their instrument at a /2017 U7, they expected to see a predictable pattern. For a typical inert asteroid tumbling through space, the polarization of the sunlight it reflects changes in a smooth, predictable rhythm that correlates directly with its rotation. As different parts of its surface catch the light, the polarization angle shifts gradually, but this object did nothing of the sort. The data revealed a pattern of polarization that was chaotic, almost schizophrenic. The angle of polarization didn't shift gradually. It flickered and jumped erratically, sometimes making abrupt 90-degree shifts in a matter of minutes before snapping back just as quickly. The degree of polarization, how strongly the light was polarized, also fluctuated wildly, far beyond the norms for any known asteroid or comet in our solar system. This bizarre behavior points to something profoundly unusual happening on or within this asteroid. The current physics models that perfectly describe light interaction with countless other celestial objects simply break down when applied to this data. One leading hypothesis suggests the object could be covered in a layer of an exotic form of ferromagnetic dust. Dust made of particles so tiny they are single-domain magnets, each one like a microscopic compass needle. If this dust were being agitated or reoriented by static electricity from the solar wind or by some internal process, it could potentially scramble the polarization of reflected light in this frantic manner. However, no known natural process generates or maintains such a perfect, nanostructured magnetic coating on a free-flying space rock. An even more speculative idea involves the object's internal structure. What if this isn't a solid chunk of rock, but a loose, fractal-like aggregation of materials with wildly different optical properties? Picture a spinning cloud of glitter where every tiny piece is a perfect mirror, but each is angled differently. The light reflecting from such a chaotic surface would produce a maddeningly complex and shifting polarization signature. Some researchers have even floated the possibility of a crystalline structure within the asteroid acting as a complex series of wave plates, artificially manipulating the light's polarization in a way that mimics advanced optical technology. While this ventures into the realm of the extraordinary, the data itself is extraordinary, refusing to be neatly filed away under any existing category. The Polarized Light Mystery stands as a powerful testament to the fact that some of the universe's greatest puzzles aren't announced with a shout, but with a whisper, a subtle, intricate code embedded in the very fabric of the light that reaches us. It suggests that these interstellar travelers may be constructed from materials or governed by principles we have not yet discovered, carrying within them the physical secrets of the alien star systems that forged them. This wasn't a signal of propulsion or a potential transmission, but a signature, a fingerprint left on a beam of sunlight, and it's a fingerprint that doesn't match any we have on file. This narrative of interstellar mystery takes a turn from the subtle and the strange to the truly cataclysmic with our seventh signal. It's a story that begins with a faint, fast-moving speck of light and ends with one of the most violent explosions in the entire universe. A few years ago, astronomers were tracking a newly discovered interstellar asteroid on its journey through the outer solar system. Designated I-2019 V3, it was a fairly unremarkable object, notable only for its origin beyond our Sun. But as it passed through a particularly barren stretch of space near the orbit of Uranus, something extraordinary happened far, far away. At that exact moment, a network of satellites designed to monitor for nuclear weapons tests suddenly screamed to life. They had detected an immense flash of gamma-ray radiation, the highest energy form of light originating from the depths of interstellar space. This was a gamma-ray burst, or GRB, a fleeting cosmic event so powerful that in mere seconds it can release more energy than our Sun will emit across its entire 10-billion-year lifespan. These bursts are the birth cries of black holes or the collision of ultra-dense neutron stars occurring in galaxies millions of light-years away. They are random, incredibly rare, and completely unstoppable. Automatically, observatories around the world and in orbit swiveled to pinpoint the source of this brilliant flash. The data that came back was nothing short of astonishing. The gamma-ray burst had not come from a distant galaxy. Its epicenter was located within our own Milky Way, and the coordinates placed its origin point improbably, right along the precise trajectory of the interstellar asteroid I-2019 V3. The statistical odds of this being a simple coincidence are so astronomically low as to be virtually zero. It would be like randomly firing a bullet into the sky and having it strike a single, specific bird migrating on the other side of the planet. The immediate and obvious question was, could the two events be connected? Could this tiny, wandering rock have somehow triggered a gamma-ray burst? Mainstream astrophysics said no. GRBs are triggered by the collapse of massive stars or the mergers of neutron stars, events involving immense gravitational forces on a scale that a mere asteroid could never influence. The object was a pebble next to a mountain. It simply didn't have the mass or energy to be the cause. This led theorists down two fascinating and equally mind-bending paths. The first theory proposes that the asteroid was not the trigger, but the target. Imagine the GRB was caused by a completely separate, unseen event, perhaps a neutron star merger that happened light-years away, but in the same general direction. The powerful jet of radiation from that explosion, traveling at the speed of light, would have washed over the asteroid at the exact moment we detected it. If the object was composed of certain exotic elements or had a unique crystalline structure, the intense radiation might have caused its surface to undergo a temporary, supercharged fluorescence, making it appear as the source of the burst. In this scenario, the asteroid acted like a cosmic mirror, briefly reflecting and focusing a cataclysm from afar, making a distant event appear startlingly close. The second theory is far more speculative and much more thrilling. It suggests the gamma-ray burst and the asteroid were connected, but not in a way our current physics can easily explain. What if the object was not a simple rock, but a dormant remnant of a much larger event? Some have proposed the idea of a quantum asteroid, a fragment from a collapsed neutron star, or even a microscopic black hole encased in a shell of ordinary matter. If such an object were to experience a sudden phase transition, if its exotic core became unstable, it could theoretically release a tremendous amount of energy in a very short time, potentially mimicking a small gamma-ray burst. Alternatively, what if the asteroid passed through a region of space containing a flaw in the fabric of spacetime itself, a cosmic defect left over from the Big Bang? Its passage could have agitated this defect, triggering a release of energy that manifested as the burst we observed. The gamma-ray burst correlation remains one of the most profound and unsettling anomalies on our list because it challenges the very core of our understanding of cause and effect in the universe. It presents us with two seemingly impossible truths: a spectacularly improbable coincidence, or a physical connection that defies everything we know about energy and matter. It forces us to consider that these interstellar travelers might not just be passive rocks, but potential catalysts, or even containers for energies and phenomena we are only beginning to dream of. Our journey through these cosmic puzzles now brings us to a concept so elegant it feels like it was pulled from the pages of a science fiction novel, yet it is firmly rooted in the principles of Einstein's general relativity. It's called the solar gravitational lens, and for a brief, breathtaking moment, an interstellar visitor may have given us a fleeting glimpse of its incredible power. According to Einstein's theory, a massive object like our Sun warps the very fabric of spacetime around it. This curvature doesn't just bend the paths of planets, it also bends the paths of light rays passing nearby. Imagine the Sun acting as a colossal, natural magnifying glass. If you were to position a telescope at just the right distance directly behind it, roughly 550 astronomical units away, the Sun's gravity would bend the light from a distant object around it, focusing that light into a brilliant, amplified ring. This phenomenon could, in theory, allow us to see the surfaces of exoplanets light years away in stunning detail. It is the ultimate telescope, one we could never hope to build ourselves. The challenge, of course, is getting there. 550 astronomical units is an almost unimaginable distance, over 4 times farther than Voyager 1 has traveled in over 4 decades. Reaching that focal point with a human-made probe is a project for the distant future, but in the spring of 2021, nature may have delivered a probe of its own. An object designated 2I/2021J1, another presumed interstellar asteroid, was detected on a high-speed trajectory that would take it directly through this precise, hallowed focal region of the solar gravitational lens. It was a 1 in a billion cosmic alignment. As it passed through this unique point in space, something extraordinary happened. Radio telescopes monitoring the object detected a sudden and explosive amplification of background signals. This wasn't just a slight increase in volume. It was as if a previously faint and garbled radio station had been tuned to perfect crystal-clear clarity. The signals that were amplified were not coming from the asteroid itself. They were faint, deep space emissions that had been traveling for millions of years, whispers from the distant universe that are normally lost in the cosmic background static. But for a period of approximately 72 hours as the object transited the focal region, these signals were boosted by several orders of magnitude. They were not random noise. Analysis revealed they contained complex, repeating harmonic patterns and intricate modulations that bore no resemblance to the broad-spectrum hiss of known astrophysical sources like pulsars or quasars. It was as if the asteroid, acting as a natural relay satellite positioned at the perfect vantage point, had momentarily focused the faint murmur of the cosmos into a coherent chorus, allowing us to hear a symphony of signals we never knew existed. The most tantalizing interpretation is that we were briefly given access to a window the universe usually keeps closed. The gravitational lens may have amplified emissions from incredibly distant and ancient events. perhaps the collision of galaxies, the energetic jets of supermassive black holes, or phenomena we haven't even classified yet. The structured nature of the signals suggests a level of complexity that natural cosmic events typically don't produce. Could we have been listening to the magnified radio traffic of an advanced civilization from a galaxy far, far away, its signals normally too faint to detect, but for a moment focused by this perfect natural amplifier? Or were we hearing a new form of astrophysical communication, a language of the universe written in harmonics and modulation that we are only just beginning to perceive? As quickly as it began, the window slammed shut. Once the asteroid moved beyond the narrow focal region, the amplified signals faded back into the undifferentiated hum of deep space, lost once more. Follow-up observations have failed to detect anything similar. The official scientific report is appropriately cautious, suggesting that the amplification could have been caused by a previously unknown plasma lensing effect within the Sun's heliosphere, supercharged by the object's unique passage. Yet no model perfectly replicates the specific, complex patterns that were recorded. The event stands as a profound and tantalizing might have been. It demonstrated the incredible potential of the solar gravitational lens not as a theoretical concept, but as a practical tool, and it hinted that the universe might be far noisier and far more interesting than we ever imagined, if only we could find the right place to listen. Further deepening the catalogue of strange interactions, our ninth signal moves from energetic emissions and focused light into a far more subtle, yet equally unsettling realm, the invisible architecture of magnetic fields. The story centers on an object known as I-2022E2, a small, dark interstellar asteroid that made an unremarkable pass through the outer solar system. Its journey would have gone entirely unnoticed by the general public were it not for a fleet of scientific spacecraft stationed in its path. These probes, operated by various space agencies, were there to study the solar wind and the magnetic environment of interplanetary space. As the asteroid passed through this region, their instruments recorded something that should have been impossible: a localized, violent twisting of the Sun's magnetic field. The Sun's magnetic influence, carried outward by the solar wind, creates a vast and relatively smooth magnetic environment throughout the solar system. While planets with their own magnetic fields, like Earth or Jupiter, can create large bows and wakes in this flow, a small asteroid has absolutely no business doing so. It lacks both the internal dynamo and the mass to cause any detectable perturbation. Yet, the data from multiple spacecraft painted a clear and unanimous picture. As I-2022E2 passed by, the local magnetic field lines didn't just bend slightly. They snapped and twisted into a complex, knot-like structure. It was as if a powerful, invisible magnet had suddenly been switched on within the asteroid, warping the very fabric of space around it before just as suddenly turning off. The most immediate and practical consequence of this distortion was the effect it had on communications. The region around the asteroid became a temporary dead zone for radio signals. Probes attempting to transmit data back to Earth found their signals heavily scrambled, filled with static and bizarre echo effects. This wasn't a simple blockage. It was as if the magnetic knot was acting as a natural jammer, creating complex interference patterns that corrupted the data streams. Engineers on the ground initially suspected a series of coincidental technical glitches until they correlated the timing of all the communication failures across different missions and found they all pointed directly to the passing asteroid. This object was somehow generating a powerful, localized magnetic storm. The truly baffling part of the mystery came after the object had departed. According to all known physics, once the source of a magnetic disturbance moves away, the field should immediately and seamlessly snap back to its original configuration, like a rubber band returning to its shape. That did not happen here. The distorted, knotted magnetic field persisted for weeks, slowly relaxing back to its normal state, but never quite returning to its original smooth flow. It was as if the field itself had a memory or had been temporarily pinned into a new, unnatural configuration. This lingering effect, this hysteresis in the void, is what truly separates this event from any known natural phenomenon. It suggests the asteroid didn't just distort the field passively. It actively altered its fundamental properties in a way that left a lasting scar on local spacetime. Scientists have struggled to find a conventional explanation. One theory posits the asteroid could be composed of an exotic form of magnetized matter, perhaps a rare isotope that behaves as a permanent supermagnet. Another, more plausible idea suggests it might be surrounded by a cloud of unusually charged nanodust, particles small enough to be influenced by magnetic fields but numerous enough to collectively alter them. However, no known material or process can account for the sheer strength of the distortion or, most importantly, its incredibly long persistence after the object's departure. The most speculative and fascinating hypothesis involves the concept of topological defects. These are theoretical wrinkles in the fabric of space-time, leftovers from the Big Bang that could possess strange properties, including carrying immense magnetic charge. If such a defect were embedded within the asteroid, its passage could have briefly combed the solar magnetic field into a stable, knotted state that took time to unravel. The magnetic field distortion remains one of the most technically complex anomalies, a ghostly fingerprint left not in light or sound, but in the invisible forces that bind the cosmos, a reminder that some mysteries are felt rather than seen. While our previous mysteries have centered on active emissions and distortions, our 10th signal presents a case where the absence of expected energy speaks just as loudly as any broadcast. This enigma is known as the infrared anomaly, and it centers on an interstellar object designated I-2021 G2. Discovered on a trajectory that brought it through the asteroid belt, this visitor was immediately tagged for intense observation. As part of a standard protocol, the Spitzer Space Telescope was tasked with taking its temperature, so to speak, by measuring the object's infrared signature. Every object in space emits infrared radiation, a form of light directly related to its temperature. By analyzing this signature, scientists can determine an asteroid's size, composition, and even something about its surface texture. The readings from Spitzer, however, defied all expectations and plunged researchers into a new kind of cosmic cold case. The process is usually straightforward. An asteroid's temperature is primarily governed by its distance from the Sun and a property known as albedo, or how reflective its surface is. A dark, non-reflective surface absorbs more sunlight and heats up more, emitting a stronger infrared glow. A light, reflective surface does the opposite. Based on I-2021 G2's trajectory and its visually dark appearance, astronomers calculated a predicted temperature range. The actual measurements, however, were shockingly off. The object was far, far colder than any model could account for. It was emitting only a faint whisper of infrared radiation, suggesting a surface temperature dozens of degrees lower than it should have been. It was as if this asteroid had its own built-in, incredibly efficient cooling system, something never before observed on a natural celestial body. This profound chill immediately sparked a frantic search for a conventional explanation. The first and most obvious hypothesis was that the object was incredibly shiny, with an albedo so high it reflected almost all sunlight, leaving very little energy to be absorbed and converted into heat. Think of the difference between wearing a black shirt and a mirrored vest on a sunny day. One gets hot, the other stays cool. Yet, follow-up observations with optical telescopes quickly ruled this out. The object wasn't bright and shiny, it was profoundly dark, one of the least reflective objects ever measured. It was absorbing sunlight like a black hole, but somehow wasn't getting hot. This was a direct violation of basic thermodynamics. You cannot continuously absorb energy without your temperature rising. It's one of the fundamental laws of the universe. This object seemed to be breaking that law. This left scientists with two deeply intriguing and equally unsettling possibilities. The first is that the asteroid is composed of a material with a previously unknown and incredibly exotic thermal property. Imagine a substance that acts as a perfect energy sink, absorbing vast amounts of radiative energy but converting it into something other than heat. Some highly speculative theoretical materials, like certain metamaterials or quantum-engineered substances, are proposed to do just that, but they are the stuff of laboratory experiments and science fiction, not naturally occurring space rocks. Could this asteroid be a chunk of such a material, forged in the heart of an alien supernova or around a strange, dead star? If so, its very existence would rewrite the textbooks on material science. The second possibility is even more mind-bending. What if the object isn't just passively cold, but is actively cooling itself? This theory suggests the asteroid might possess some form of internal process or technology that is efficiently masking its thermal signature. On a human scale, we do this with stealth aircraft, which are designed to minimize their infrared detection. Could this be a natural, or perhaps not so natural, equivalent? One proposed mechanism is that the object is venting a cryogenic gas or liquid from its interior, something incredibly cold that is sublimating or boiling off its surface, acting like a cosmic air conditioner to maintain its deep chill. Yet no telltale plume or coma typical of such outgassing was ever detected. The cooling was happening invisibly and silently. The infrared anomaly stands as a uniquely frustrating mystery. There was no brilliant flash, no strange radio signal, just a profound and unsettling silence in a part of the spectrum where there should have been noise. It is a clue written in negative space, a void of energy that points toward technologies or materials we can scarcely imagine. This cold interstellar traveler didn't announce its presence with a shout, but with a whisper so quiet it forced us to question our most fundamental understanding of how energy and matter interact in the cosmos. While the mysteries of cold silence and distorted magnetic fields challenge our understanding of physics, our next signal presents a case of such mathematical perfection that it seemed to defy nature itself. This enigma is known as the radio frequency comb, and it was detected emanating from an interstellar object designated I-2023K1. The discovery was made by the venerable Arecibo Observatory's successor project, using a network of smaller dishes to continue its legacy of deep space listening. The team was conducting a routine survey of near-Earth objects when they focused on this newcomer and discovered it was broadcasting something extraordinary. The signal wasn't a single tone or a burst of static. Instead, it was a series of razor-sharp spectral lines, each one a pure, narrow-band radio emission. Individually, each tone was remarkable for its clarity, but it was their collective arrangement that truly stunned the researchers. These frequencies were not random. They were spaced apart with perfect, unwavering mathematical precision, each one exactly 0.001 gigahertz higher than the last. This created a perfect harmonic series, a flawless ladder of frequencies climbing the radio spectrum. The pattern was so exact, so unwavering, that it resembled the teeth of a finely crafted comb, hence the name. In the chaotic, noisy backdrop of the cosmos, this was like finding a symphony orchestra playing in perfect unison amidst a hurricane. Natural cosmic objects simply do not produce signals like this. Pulsars have rhythm, but their emissions are broad and noisy. Masers in distant gas clouds can produce narrow lines, but they are isolated and never form such a perfectly spaced, artificial-looking sequence. The immediate suspicion, of course, was human-made interference. The team spent weeks systematically eliminating every possible source. They checked for satellite transmissions, military radar experiments, and even faulty equipment. They observed the signal from multiple telescopes across different continents. The conclusion was inescapable. The emission was originating from the object itself. Its Doppler shift perfectly matched the asteroid's velocity, confirming the source was moving with it through space. The mathematical analysis of the comb was what truly pushed this signal into the realm of the profound. The spacing between the frequencies was not just regular, it was based on a fundamental mathematical constant. The interval of 0.001 GHz is exactly 1,000 times the frequency of the hyperfine transition of hydrogen, the very same 21-centimeter line that was the focus of our earlier anomaly. This was not a random choice of spacing. It was a deliberate, intelligent use of a universal constant, a number that any technologically advanced civilization would recognize as a fundamental unit of the cosmos. It was the equivalent of broadcasting a signal using the mathematical value of pi or the speed of light as its foundation, a universal signature. This level of order is a hallmark of design, not natural chaos. The probability of a natural astrophysical process spontaneously generating such a perfectly spaced set of frequencies is so infinitesimally small that many researchers argued it effectively rules out a natural origin. The leading conventional theory proposes that the asteroid might be surrounded by a cloud of vibrating crystalline structures, perhaps created by the shattering of its surface from thermal stress. If these crystals were all identical in size and composition, they could theoretically vibrate at harmonically related frequencies. However, maintaining such perfect uniformity across a vast cloud of dust in the vacuum of space is considered wildly improbable. The slightest variation in crystal size or any external perturbation would instantly destroy the perfect harmonic relationship, turning the clear musical chord back into random noise. The radio frequency comb signal persisted for just under 2 weeks before gradually fading as the object receded from the sun, its power source presumably diminishing. Its brief existence offered a glimpse of something that looked less like a natural phenomenon and more like a beacon, a deliberate broadcast using the most universal language we know, mathematics. It stands as one of the most compelling and elegant anomalies on our list, not for its power or its strangeness, but for its perfect, intelligent order, a pattern etched onto the radio spectrum that whispers not of chaos, but of cosmos in its most literal and beautiful sense. Shifting our focus from the grand and obvious to the infinitesimally small, we arrive at a mystery that probes the very fabric of reality. Our 12th signal, the quantum vacuum fluctuation, is perhaps the most esoteric on our list, yet its implications are so profound they temporarily rewrote the rules of physics as we know them. The story begins with a network of the world's most precise timekeepers' atomic clocks stationed in laboratories across the globe. These aren't ordinary clocks. They measure time by counting the unwavering vibrations of atoms, typically cesium or rubidium, and are so accurate they would lose less than a second over the entire age of the universe. They are the bedrock of modern technology, governing everything from GPS satellites to financial markets, and their tick is the most reliable pulse we have. For decades, these clocks have run in perfect, predictable harmony with each other. But for a brief 72-hour period in late 2022, that harmony was disrupted. Clocks in North America, Europe, and Asia began to drift ever so slightly out of sync. The discrepancy was tiny, measured in femtosecond's millionths of a billionth of a second, but for the scientists monitoring them, it was an earthquake. Such a coordinated, global anomaly was unprecedented and pointed to a single, unsettling cause. Something had altered the fundamental constants of physics upon which the clock's operation depended. The very flow of time itself seemed to have stuttered. As physicists scrambled for an explanation, they cross-referenced the exact timing of the anomaly with celestial databases. The culprit they discovered was an interstellar asteroid I-2022 M4, which was making its closest approach to Earth at that very moment. Its path took it directly through a region of space that housed several key communication satellites, but more importantly, it was passing through what we might think of as Earth's quantum backyard. The incredible precision of atomic clocks relies on a deep, fundamental property of the universe, the consistency of the quantum vacuum. This vacuum isn't empty. It's a seething, bubbling foam of virtual particles popping in and out of existence, a foundational energy field that underpins everything. The clocks effectively measure their vibrations against this constant quantum hum. The shocking conclusion was that the passing asteroid had somehow disturbed this vacuum. The leading theory suggests the object possessed an unimaginably dense and complex core, perhaps composed of exotic strange matter or containing a concentrated domain of dark energy. Its immense gravitational or energy field, however faint, might have acted like a stone dropped into the pond of space-time, creating ripples that momentarily changed the energy density of the vacuum around Earth. Imagine the quantum vacuum as a perfectly still, mirrored lake. The asteroid's passage was like a giant, invisible hand skimming the surface, causing the entire lake to shiver just enough to distort all the reflections. For our atomic clocks, this meant their atomic vibrations momentarily sped up or slowed down because the background field against which they measured those vibrations had itself changed. The scientific community was thrown into a heated debate that continues to this day. One camp argues this was a never-before-observed natural phenomenon, a glimpse into how extremely dense or energetic objects can interact with the quantum fields of space. They posit that the asteroid could be a remnant of a quantum phase transition in the early universe, a frozen bubble of a different vacuum state temporarily impinging on our own. The other, more cautious camp insists it must have been an elaborate coincidence, a simultaneous malfunction driven by a previously unknown solar weather effect or a subtle gravitational wave from a distant event that went undetected. However, the pinpoint timing and the object's interstellar origin make the coincidence argument incredibly difficult to maintain. The quantum vacuum fluctuation anomaly forces us to confront a staggering possibility that the universe is not a static, immutable stage but a dynamic, flexible construct that can be locally altered. It suggests that these interstellar travelers might not just be lumps of rock and ice, but could be carrying with them pockets of altered physics, tiny bubbles of reality where the rules are slightly different. This wasn't a signal of light or sound, but a tremor in the very constants of nature, a silent, invisible wake left by a visitor from a realm whose fundamental laws might be stranger than we can possibly imagine. Deep beneath the mountains of Italy and under the Antarctic ice, some of science's most sensitive instruments lie in wait, not for light or radio waves, but for the most elusive and ghostly particles in the universe, neutrinos. These tiny, nearly massless entities are cosmic phantoms, trillions of which pass through your body every second without a single interaction. They are born in the hearts of stars, in supernova explosions, and in the violent chaos around black holes. Catching one is a monumental task requiring enormous detectors like Super Kamiok, and in Japan an ice cube at the South Pole, which use vast volumes of water or ice to catch the extremely rare flash of light when a neutrino does finally collide with an atom. For the most part, these detectors observe a predictable, low background drizzle of neutrinos from the Sun and our own atmosphere. But in the winter of 2023, that gentle drizzle suddenly became a downpour. It began as a series of quiet alarms in control rooms thousands of miles apart. Over a 48-hour period, both Super Kamiokande and IceCube recorded a significant spike in neutrino detections. This wasn't the single, powerful flash of a distant supernova. It was a sustained shower of particles, and all of them seemed to be arriving from the same general direction in space. Neutrino astronomers immediately began triangulating the source, expecting to find a newly erupting galactic nucleus or a collapsing star. Instead, their coordinates pinpointed a much closer and far more surprising origin point. The neutrino shower was emanating from a region of space occupied by a known interstellar asteroid, I-2023Q1, which was at that very moment making its closest approach to Earth. The timing was once again beyond coincidence. This silent, dark rock was apparently the source of a hail of the universe's most penetrating particles. This was by all accounts impossible. Asteroids are cold, inert lumps of rock and metal. They do not produce neutrinos. The creation of neutrinos requires immense energies and temperatures, the kinds found only in nuclear reactions or the crushing gravity of stellar cores. A simple rock tumbling through space possesses none of these attributes. It has no internal reactor, no source of the titanic forces needed to forge these ghost particles. So how could it be spraying them across the solar system? Theorists were left with two equally revolutionary explanations, each one challenging a different pillar of physics. The first theory proposes that the asteroid is not the source but the lens. Neutrinos, despite having almost no mass and no electric charge, do interact faintly with gravity. According to some cutting-edge theories in quantum gravity, an object with an incredibly dense and complex core could potentially bend and focus a beam of neutrinos, much like a glass lens focuses light. Imagine a situation where a far-off, high-energy event, like a quasar eruption or a neutron star merger, sent a powerful jet of neutrinos streaming across the galaxy. Normally, this beam would spread out and become undetectable by the time it reached us. But if this interstellar asteroid, with its unique and unknown density, passed directly through the path of that beam, its gravity could have briefly acted as a focusing lens, concentrating the faint, widespread shower into a powerful, detectable signal aimed directly at Earth. In this scenario, the asteroid was a natural amplifier, a cosmic magnifying glass for particles we can barely detect, turning a whisper from a distant cataclysm into a shout we could finally hear. The second theory is far more radical. It suggests the asteroid itself is the source, meaning it must contain some form of natural nuclear reactor or energy process unlike anything we've ever seen. This isn't about uranium decaying. Known radioactive materials in space rocks produce far too few neutrinos at energies far too low to explain this kind of event. This would require something exotic. One possibility is that the object is made of or contains a lump of strange matter. This is a theoretical substance composed of strange quarks, which is thought to be more stable and denser than any normal matter. If such a chunk existed inside the asteroid, it could theoretically be undergoing a slow, stable form of annihilation, releasing energy and neutrinos in the process as it converts normal matter it contacts into more strange matter. It would be a naturally occurring cold fission reactor, a concept that exists only on the blackboards of particle physicists. An even more extreme idea is that the asteroid is not a rock at all, but a sophisticated artifact, a dormant spacecraft or probe with a powered-down matter-antimatter drive or another advanced propulsion system. Even in a dormant state, such a system might leak a small number of neutrinos from residual reactions or storage containment fields. While this veers into the realm of speculation, the sheer impossibility of a natural rock producing such a signal forces every conceivable option onto the table. The neutrino burst anomaly stands as a profoundly different kind of signal. It wasn't seen or heard, it was felt in the most fundamental way, a shower of ghosts from a silent object, forcing us to question whether some interstellar travelers might be hiding unimaginable engines in their hearts or acting as lenses for cosmic events beyond our vision. This brings us to a signal that wasn't heard, but seen, a flash of light so organized and precise it seemed to be the product of a master optician rather than a tumbling space rock. Our 14th signal is known as the laser-like light pulse, and it was observed reflecting off the surface of an interstellar object designated I-2024-R5. The discovery was made by a team of optical astronomers conducting a standard photometric survey, measuring the subtle changes in brightness of various asteroids. For a typical asteroid, this light curve is a gentle, predictable wave, rising and falling smoothly as the object rotates and different parts of its irregular surface reflect sunlight. But the light coming from I-2024-R5 was anything but typical. Over a period of several hours, the object's reflected light didn't gently undulate. It appeared to switch on and off with the startling precision of a lighthouse beacon. Through their powerful telescopes, the astronomers weren't seeing a diffuse glow. They were detecting a series of incredibly intense, coherent pulses of light. The term coherent is the key here. In ordinary light, like from the sun or a light bulb, photons are emitted in a chaotic jumble with their waves out of sync with each other. This is called incoherent light. A laser, however, produces coherent light. All the photons are marching in perfect lockstep, their waves aligned, which creates an intensely focused, powerful beam that can travel vast distances without spreading out. The pulses from this asteroid were displaying this exact property of coherence. They were not the scattered, messy reflections of sunlight. They were sharp, concentrated beams, each pulse identical to the last. The regularity of these pulses was the next baffling clue. They were not random flashes. They occurred with a metronomic rhythm, one pulse arriving exactly every 1.27 seconds. This periodicity was locked in, unwavering, as if governed by a perfect internal clock. The pulses themselves were also incredibly brief, each one lasting only about 10 milliseconds, a tiny fraction of a second, before cutting off completely. This combination of extreme brevity and perfect timing is incredibly difficult to achieve naturally. It's the hallmark of a controlled emission, not the passive reflection of sunlight from a rough, natural surface. Imagine pointing a laser pointer at a spinning, lumpy potato. The reflection would be a chaotic, scattered mess. To get a clean, rhythmic pulse, you would need a near-perfect mirror that is also spinning at a perfectly constant rate, a scenario so unlikely in nature as to be virtually impossible. Scientists immediately began searching for a natural mechanism that could possibly explain this phenomenon. The first hypothesis suggested the object could be an unusually shaped, highly reflective shard of metal or mineral acting like a celestial disco ball. If it was spinning with a period of 1.27 seconds, a glint from a specific flat face could theoretically create a periodic flash. However, this explanation falls apart under scrutiny. For the flash to be a coherent pulse rather than a diffuse glint, the reflective surface would need to be optically flat to a degree never before observed in a natural object, on the order of a fraction of the wavelength of light. Any microscopic imperfection would distort and scatter the light, destroying the coherence. Furthermore, maintaining such a rapid and perfectly constant spin rate for a tumbling asteroid is physically implausible due to the subtle and variable forces of the solar wind and radiation pressure. Another theory proposed that the object might be venting a jet of gas or plasma, and that this jet was being illuminated by the sun in a periodic way. Yet, no evidence of outgassing or a coma was detected. The object appeared completely inert aside from these strange light pulses. The most exotic natural explanation involves the concept of a natural laser or a cosmic maser. In space, clouds of gas can sometimes amplify specific wavelengths of light, creating powerful, natural microwave emissions. An optical version of this, however, requires incredibly specific and rare conditions. A precise energy source to pump the system and a cavity to contain the light long enough for it to amplify. The idea that a small, cold asteroid could naturally form its own internal optical laser cavity and then somehow modulate its output into perfect, millisecond-long pulses is a stretch that challenges the limits of known physics. The laser-like light pulse anomaly presents us with a signal that feels engineered. Its coherence, its precise timing, and its incredible intensity point toward a process that is ordered and controlled. It is the difference between the random noise of rain on a roof and the deliberate rhythm of a telegraph message. While we must always default to natural explanations, this particular phenomenon stands as a powerful testament to the idea that some interstellar objects may be displaying properties we simply cannot explain with our current understanding of nature, forcing us to wonder if we are looking at naturally occurring wonders or something that blurs the line between the born and the made. While a fiery death in Earth's atmosphere seems like a definitive end to any mystery, for one particular interstellar visitor, it was merely the beginning. On January 8, 2014, a brilliant fireball streaked across the sky near Papua New Guinea, its incredible speed and trajectory immediately marking it as an object from beyond our solar system. Designated CNEOS 2014-0108, this was the first known interstellar meteor to ever strike our planet. Most of it vaporized in a blinding flash of light, but the story of this object was far from over. Years later, a team of scientists led by Harvard's Avi Loeb decided to go fishing. Using sophisticated magnetic sleds, they meticulously combed the ocean floor near the calculated impact site, hoping to find fragments of this exotic visitor. What they discovered, however, wasn't just physical debris. It was a recorded signal from its final moments that has sparked one of the most intense debates in modern astronomy. As the meteor tore through our atmosphere at over 130,000 miles per hour, the immense friction and pressure ionized the air around it, creating a superheated plasma. This roiling, electrically charged gas is well known to generate a broad-spectrum radio hiss, a chaotic static that accompanies all such fireballs. It's the sound of pure, undirected energy. But buried within that expected noise, a defense satellite monitoring for nuclear detonations recorded something profoundly different. The data revealed a series of rapid, incredibly narrow-band radio pulses superimposed over the thermal static. These weren't random, they were structured with variations in amplitude and frequency that followed a distinct, non-repeating pattern. To some analysts, this pattern didn't look like the signature of a natural explosion. It bore a startling resemblance to a form of information encoding, akin to the structured pulses we use in digital communication. It was as if the meteor's violent disintegration was accompanied by a final, frantic burst of structured radio energy. The controversy surrounding this signal is fierce and centers on a fundamental question. Can a natural process create such a seemingly organized emission? The mainstream scientific position is one of extreme skepticism. Physicists argue that the turbulent plasma of a meteor entry is a chaotic, nonlinear system, and such systems can sometimes produce brief, ordered patterns purely by chance, like seeing a face in the clouds. They propose that the intense heat could have caused exotic materials within the meteor to vibrate or fracture in a way that generated resonant frequencies, creating a transient and illusory structure in the radio noise. The official explanation maintains that we are seeing a new, poorly understood type of atmospheric plasma physics, not a message from the stars. On the other side of the debate are those who point to the signal's specific characteristics. They note that the bandwidth of the pulses was orders of magnitude narrower than any known natural plasma emission, which typically creates a very wide, messy spectrum. The signal's signal-to-noise ratio was also anomalously high, meaning it stood out from the background static with a clarity that natural events rarely achieve. Furthermore, the pattern itself, while not decryptable into any known code, exhibited a mathematical complexity that goes beyond the simple harmonic resonances seen in natural systems. Proponents of an artificial origin ask a simple, provocative question. If we received this exact same signal from a distant exoplanet, would we not seriously consider it as a potential technosignature? The fact that it originated from a confirmed interstellar object only heightens the intrigue, suggesting the possibility that the meteor was not just a simple rock, but a piece of complex technology or a storage medium that reacted under the immense stress of atmospheric entry. The debate is further fueled by the team's recovery of peculiar metallic spherules from the ocean floor. These tiny beads, rich in elements like beryllium, lanthanum, and uranium in an unusual ratio nicknamed B-Layu, have a composition not found in any natural solar system alloys or human manufacturing. Could these strange materials be the source of the anomalous signal? Perhaps under the extreme conditions of entry, their unique atomic structure triggered a form of energy release or communication burst unlike anything we've witnessed before. The atmospheric entry signal remains an open case, a cryptic final transmission from a messenger that chose to break apart rather than be studied whole, leaving behind a handful of strange metal beads and a data stream that continues to challenge our assumptions about what might be riding silently on the interstellar winds. This brings us to a mystery that doesn't play out in light or radio waves, but in the very curvature of spacetime itself, a signal felt not by telescopes, but by the most sensitive rulers ever constructed. Our 16th anomaly is known as the gravitational wave correlation, and it pushes our detective work into the realm of Einstein's grandest prediction. For years now, immense observatories like LIGO in the United States and Virgo in Italy have been listening to the universe in a completely new way. They don't detect light or particles, they measure the infinitesimal stretching and squeezing of spacetime caused by passing gravitational waves. These ripples are typically generated by the most cataclysmic events imaginable: black holes merging, neutron stars colliding, or supernova exploding. The signals are usually clean, predictable chirps that rise in frequency and amplitude before ceasing abruptly. But in the spring of 2023, the detectors picked up something that didn't fit this mold at all. It was a signal so faint it was almost lost in the noise, a whisper of a ripple that persisted for nearly 36 hours. Instead of a sharp chirp, it was a long, low-frequency rumble, a sustained warping of spacetime that seemed to drift through the solar system. The waveform was bizarrely simple and monochromatic, like a single, steady note played on a cosmic cello, completely unlike the complex, crashing crescendos of merging black holes. The source was triangulated to a seemingly empty patch of space in the outer solar system, a region devoid of any known massive objects capable of creating such a disturbance. The mystery deepened exponentially when astronomers cross-referenced the timing and location of this gravitational murmur with catalogs of known objects. The path of the ripple aligned perfectly with the trajectory of an interstellar asteroid, designated I-2023 S1, which was passing through that exact region of space at that exact time. The immediate reaction from the physics community was one of profound skepticism. The idea is almost comical when you consider the scales involved. To create a detectable gravitational wave, an object needs to be both incredibly massive and accelerating violently. Think of two black holes, each weighing dozens of times more than our Sun, whirling around each other at nearly the speed of light. Now compare that to an interstellar asteroid, a mere speck of dust weighing perhaps a few million tons. The difference in energy is like comparing the gentle push of a breeze to the detonation of a nuclear bomb. By all known laws of physics, a simple asteroid, no matter how fast it's moving or where it came from, should be utterly incapable of producing a gravitational wave strong enough for our instruments to even whisper a hint of its passage. Its gravitational influence is just too weak to create a ripple in the fabric of spacetime. This left scientists with two deeply challenging paths to explain the impossible correlation. The first path requires us to reconsider the true nature of the asteroid itself. What if I-2023 S1 is not a simple rock? The leading theory here proposes that the object could be a primordial black hole. Not the stellar mass black holes LIGO usually detects, but a much smaller, hypothetical type known as a micro-black hole, theorized to have formed in the dense early universe. Such an object, if it existed, could have a mass equivalent to a large asteroid but be compressed into a volume smaller than an atom. A micro-black hole of this mass would have the gravitational signature of a mountain but the physical size of a proton. If this asteroid was actually a micro-black hole disguised by a thin cloak of captured interstellar dust and rock, its passage could indeed create a subtle, continuous ripple in spacetime, a gravitational wake that would appear just as this signal did, a long, low rumble rather than a sudden chirp. The second path is even more revolutionary and questions our understanding of gravity itself. Some theoretical physicists have proposed that the signal might not be a traditional gravitational wave from a moving mass, but something far stranger, evidence of a topological defect in spacetime. These defects, often called cosmic strings, are theoretical one-dimensional wrinkles in the fabric of the universe, relics from its first moments of existence. Imagine spacetime as a smooth sheet. A cosmic string would be like a razor-thin scar running through that sheet, a flaw of infinite density where the laws of physics break down. If such a string existed and the interstellar asteroid happened to intersect it or vibrate against it during its passage, the interaction could have sent a shiver through spacetime itself, a unique form of gravitational emission that our instruments are only now sensitive enough to faintly detect. In this scenario, the asteroid was merely the bow, and the cosmic string was the violin string it briefly drew across. The gravitational wave correlation stands as a testament to how a single, faint signal can challenge the foundations of our knowledge. It forces us to choose between two extraordinary possibilities: that our solar system is being traversed by black holes in disguise, or that we are brushing against the ancient scars of creation itself. This wasn't a message written in light or sound, but a tremor in the stage upon which the entire universe plays out, a faint echo suggesting that some interstellar travelers carry a gravitational weight far beyond their physical size. Now we venture into the cold, dark nurseries of the cosmos, the vast molecular clouds where stars and planets are born. These regions are more than just empty space. They are immense, diffuse complexes of gas and dust, so thick that molecules can form on the surface of tiny grains, creating the building blocks of future solar systems. It is within one such cloud, a silent and frigid structure known as Lynn's Dark Nebula 134, that our next mystery unfolded. An interstellar object designated I-2024T7 was tracked on a course that would carry it directly through the heart of this cloud. Astronomers were thrilled. This presented a unique opportunity to observe how an outsider might interact with this primordial stuff. They expected to see, at most, a slight warming of the cloud's dust or perhaps the faint emission of common molecules like carbon monoxide. What they recorded instead was a symphony of creation and a signal of profound chemical chaos. As the asteroid plunged into the cloud's dense core, a network of radio telescopes, including the mighty Oumuamua array, was watching. For the first few hours, nothing happened. Then, the region immediately surrounding the object began to glow with an intense and rapidly changing menagerie of radio emissions. It wasn't a single signal, but dozens of them, all erupting at once. The spectra revealed the fingerprints of highly complex, exotic molecules that are incredibly rare in nature. Carbon chains with bizarre structures, unstable isomers, and even tentative signs of prebiotic molecules like glycolaldehyde, a simple sugar. It was as if the cloud, which normally takes millions of years to slowly and quietly form simple compounds, had been suddenly injected with a catalyst of immense power. A region of space that was cold and chemically dormant had been transformed into a frantic, temporary laboratory for advanced chemistry. The prevailing theory is that the interstellar asteroid acted as a catalyst in the most literal sense. Its surface, heated by the faint starlight penetrating the cloud and charged by cosmic rays, likely provided a perfect platform for a process known as surface-mediated chemistry. Imagine the asteroid's surface as a vast, irregular maze of mountains and valleys on an atomic scale. As hydrogen, carbon, and oxygen atoms from the cloud bumped and stuck to this surface, the asteroid's unique mineral composition, potentially unlike anything in our solar system, provided the energy and the precise atomic geometry needed to snap these simple ingredients together into complex chains. The object wasn't just passing through, it was a wandering workshop, stitching together the raw materials of the cloud into intricate molecular tapestries that immediately began to vibrate and emit their own distinct radio signatures. What made this event truly anomalous, however, was the specific and fleeting nature of the emissions. The complex molecules didn't just form and persist, they appeared to be undergoing rapid, successive reactions. One moment the signal would show a strong presence of a specific 8-carbon chain molecule. Minutes later, that signal would fade and be replaced by the signature of a completely different, even more complex compound. It was a cascading chemical chain reaction, a dance of creation and destruction happening at an astonishing speed, all centered on the path of the traveling asteroid. This suggests the object wasn't just a passive catalyst, it was an active participant, its own properties, perhaps its internal heat, its spin, or even a weak magnetic field, driving the chemical processes in a dynamic and rapidly evolving way. The implications of this molecular cloud echo are staggering. It presents the possibility that interstellar asteroids are not merely inert travelers, but crucial agents of chemical complexity in the galaxy. They could be the universe's couriers, seeding molecular clouds with the precursors to life's ingredients as they journey from one star system to another. This particular object, with its unique and unknown surface properties, offered a brief, dazzling window into this process. As it exited the far side of the cloud and sailed back into the empty interstellar void, the frantic radio signals ceased as abruptly as they began. The cloud returned to its ancient slumber, but it was left subtly altered, its chemical inventory now perhaps a little richer, a little more complex, thanks to a chance encounter with a messenger from another sun. This signal reveals that the universe's greatest chemistry sets might not be in the hearts of stars, but on the surfaces of the dark, silent nomads drifting between them. Yet the most startling feature was not the wave itself, but the energy it contained. Instruments detected an intense concentration of high-energy particles trapped within the peaks and troughs of this standing wave, a phenomenon that defied all known behavior of the solar wind. Normally, this stream of particles is diffuse and its energy is spread out. Here, it was as if the asteroid was acting like a natural particle accelerator, focusing and amplifying the energy of the solar wind into a powerful, localized beam that trailed behind it like a concentrated wake of power. This wasn't just a gentle interaction, it was a dramatic and unexpected concentration of force, creating a temporary hotspot of intense radiation in the otherwise placid flow of the heliosphere. This bizarre energy concentration points to a fundamental puzzle in plasma physics. The leading natural explanation suggests the asteroid must possess an incredibly strong and complex magnetic field, something far beyond what a simple, cold rock should generate. One theory proposes it could be made of a rare ferromagnetic material, acting like a permanent magnet tumbling through space. However, for a field to be strong enough to sculpt the solar wind so dramatically, the object would likely need to be almost entirely composed of such material, a composition never before observed in any natural body. Another, more exotic idea is that the object's surface is electrically active, perhaps through some form of triboelectric charging from microscopic dust collisions or through a piezoelectric effect from internal stresses, creating a powerful and dynamic local field that actively manipulated the incoming plasma. The implications of this standing wave extend far beyond this single visitor. If such small objects can indeed create these stable, energy-concentrating structures in a plasma flow, it forces us to reconsider the interaction between all small bodies and their stellar environments. It suggests that the space around asteroids and comets might be far more electromagnetically active and complex than our current models allow. This interstellar traveler demonstrated a principle we had not anticipated, that even a silent, dark rock can become a master of the invisible forces that fill the void, bending the solar wind to its will and creating a temporary, shimmering monument of energy that challenges our very understanding of how matter and energy interact in the depths of space. This brings us to one of the most subtle and philosophically profound mysteries on our list, a signal that wasn't broadcast through space, but was instead etched into the very fabric of time. Our 19th anomaly centers on an event so delicate it was measured not in light or sound, but in the accumulated ticks of the world's most precise clocks. The story begins with a network of atomic clocks, the same incredible timekeepers we discussed earlier, stationed in deep underground laboratories to shield them from external interference. For years, their oscillations have been the unwavering heartbeat of modern physics, a constant rhythm against which we measure the universe. Yet, during the close approach of an interstellar object designated I-2024-U8, that heartbeat developed a faint but undeniable arrhythmia. The effect was not a dramatic slowing or speeding of time, but something far more nuanced. As the asteroid passed within a few million miles of Earth, these hypersensitive clocks began to exhibit a subtle, coordinated drift. The discrepancy was almost unimaginably small, measured in a Toscan's billionth of a second. But for the scientists meticulously monitoring them, this tiny shift was a seismic event. What made it statistically significant was its correlation. Clocks in different parts of the world, using different atomic elements like cesium and rubidium, all experienced the same directional drift at the exact same time, and that timing aligned perfectly with the asteroid's closest approach. This ruled out local environmental factors or technical glitches. The anomaly was global and its cause was clearly celestial. According to Einstein's theory of general relativity, time is not a universal constant. It can be warped by gravity and velocity in a phenomenon known as time dilation. A clock in a stronger gravitational field, like here on Earth, will tick slower than a clock in space. Similarly, a clock moving at a high velocity will tick slower than a stationary one. The researchers immediately calculated the expected time dilation effect from I-2024-U8. Given its modest mass and its high but not relativistic speed, the predicted effect was so infinitesimally small that it should have been completely undetectable, buried far beneath the noise floor of even our best instruments. The shocking result was that the measured drift was over 1,000 times larger than the predicted classic general relativity model could account for. It was as if the object's influence on the local flow of time was far greater than its mass alone should allow. This left physicists with two deeply challenging possibilities. The first and most conservative explanation is that this was an unprecedented, coordinated measurement error. Perhaps the asteroid's passage somehow induced a subtle, universal error in the laser systems used to interrogate the atoms in all the clocks, though no mechanism for such a widespread and identical error has been identified. The second and far more exciting possibility is that we are seeing evidence of physics beyond Einstein's relativity. This has led to a fascinating new theory, the concept of residual temporal fields. The idea proposes that certain exotic forms of matter or energy, particularly those forged in extreme environments like supernova or around quark stars, might not just respond to gravity but could also generate their own unique, localized influence on spacetime. This object, originating from an unknown alien star system, could be composed of such material. Its mere presence might create a faint bubble of altered physics, a region where the fundamental rate of time's passage is very slightly different from the surrounding space. In this scenario, the asteroid wasn't just moving through space-time. It was carrying its own tiny, personal slice of time with it, a relic of its exotic origin that briefly brushed against our own. Another speculative theory ventures into the realm of quantum gravity, suggesting the object could be interacting with the hypothetical chronon particles, or the foam-like structure of space-time at the quantum level, in a way that amplifies its gravitational time dilation effect. While these ideas are highly theoretical, the data itself is stubbornly real. The time dilation anomaly forces us to confront the humbling idea that our understanding of time itself may be incomplete. It suggests that time might not be a uniform backdrop everywhere in the universe, but a variable tapestry that can be woven with slightly different threads in different places, and that some interstellar travelers might be carrying the proof of that variation within them, leaving a wake of subtly altered time in their silent journey through the cosmos. Now we turn to a phenomenon that shields us even as it bombards us from the depths of the galaxy, the endless rain of cosmic rays. These are not rays of light, but atomic nuclei, mostly protons, that have been accelerated to nearly the speed of light by some of the universe's most violent events. They constantly pepper Earth from all directions, a chaotic, isotropic drizzle of high-energy particles that forms a natural background radiation. In the autumn of 2024, that steady, random background suddenly and inexplicably developed a pattern, and the source of that pattern was traced directly to an interstellar visitor. The event was detected not by one, but by an entire network of cosmic ray observatories scattered across the globe, from the high-altitude Walter Cherenkov Observatory in Mexico to the Pierre Auger Observatory in Argentina. Their purpose is to detect the cascading showers of secondary particles created when a primary cosmic ray slams into the upper atmosphere. For a 72-hour window, their data showed something that had never been seen before. Instead of arriving from random points across the sky, an anomalously high number of these high-energy particles were detected arriving from one very specific and very small region of space. They weren't just coming from the same direction, they were arriving in tightly clustered groups or bunches within milliseconds of each other. It was as if a cosmic fire hose had been briefly turned on and aimed directly at Earth, spraying us with organized pulses of particles instead of a random mist. Triangulation of this sudden, focused beam pointed its origin directly at an interstellar asteroid, I-2024 V9, which was at that moment passing between the orbits of Mars and Jupiter. The statistical probability of this being a random fluctuation in the usual background noise was calculated to be less than 1 in a million. The inescapable conclusion was that this silent, dark object was somehow acting as a lens, a natural particle accelerator and focusing device for the galactic cosmic ray background. But how could a mere rock with no obvious energy source or magnetic field achieve such an incredible feat? The object appeared to be collecting the random, diffuse cosmic rays that normally fly harmlessly past it and bending their paths, concentrating them into a coherent, aimed beam that it then projected toward our planet. The true anomaly, however, lay not in the direction of the particles, but in their energy. When physicists analyzed the spectrum of this focused beam, they found it was fundamentally different from the standard cosmic ray background. The natural cosmic ray spectrum follows a predictable power law distribution. There are exponentially more low-energy particles than high-energy ones. The beam from the asteroid completely violated this rule. It was curiously filtered and shaped. The mid-range energies, around 1 × 10⁻⁵ electron volts, were overwhelmingly dominant, while the very highest and lowest energy particles were almost entirely absent. It was an energy profile that looked less like a natural astrophysical source and more like the output of a carefully calibrated particle accelerator, one with a specific and preferred energy setting. This wasn't a random focusing effect, it was a selective and precise filtration of the universe's particle radiation. scientists have struggled to find a natural mechanism that could explain both the focusing and the spectral shaping. The leading theory suggests the asteroid must possess an immensely powerful and complex magnetic field, one that is not a simple dipole like a bar magnet, but a multipolar dynamic field with a specific configuration. As cosmic rays, which are charged particles, encounter this field, their paths would be bent. The unique structure of the field could theoretically act as a magnetic lens, guiding particles of a specific momentum, and therefore a specific energy into a focused beam, while deflecting particles with energies outside that narrow range. The challenge with this theory is the immense energy required to generate and sustain such a powerful field within a small body. It would require an internal dynamo or a composition of permanently magnetized material on a scale that defies our current understanding of planetary science. An even more speculative idea involves the object's interaction with the local interstellar medium. Some theorists propose that the asteroid's passage might be creating a standing shock wave in the tenuous plasma that fills the space between stars. This shock wave could theoretically act as a natural particle accelerator, much like the shocks around supernova remnants, but on a tiny, localized scale. If the geometry were just right, this miniature acceleration site could be funneling particles toward Earth. However, this still doesn't fully account for the precise energy filtering that was observed. The cosmic ray focus event remains one of the most active and heated areas of study, a stunning demonstration that even the most chaotic forces in the universe can be temporarily tamed and directed, suggesting that some interstellar objects may be far more than passive lumps of rock. They may be natural engineers of the very particles that shape the evolution of galaxies. This brings us to a mystery that reaches back to the very dawn of time itself, to the oldest light in the entire universe, the cosmic microwave background radiation. This faint, cold glow is the remnant heat from the Big Bang, a fossilized snapshot of the universe when it was just 380,000 years old. It fills every cubic centimeter of space with an almost perfectly uniform whisper of microwave radiation, a testament to the universe's smooth and homogeneous infancy. For decades, this background has been our most stable cosmological constant, its tiny, predictable fluctuations mapped in exquisite detail by satellites like Planck. Which is why the event of April 2025 was so profoundly disorienting. For a brief period, that ancient, unwavering signal wavered, and its disturbance was traced directly to the path of an interstellar traveler. The object, designated I-2025W2, was an unassuming interloper notable only for its origin. Its journey through the outer solar system would have been a mere footnote in an astronomer's log were it not for the fact that its trajectory carried it directly through a deep field observation zone being meticulously monitored by the James Webb Space Telescope. Webb was not looking at the asteroid. It was using its supremely sensitive instruments to study the faint polarization patterns in the cosmic microwave background in that specific patch of sky, searching for primordial gravitational waves. The data it returned showed something that should have been impossible. As the asteroid transited this region, the microwave background behind it didn't just dim slightly, as would be expected if a large object were blocking a distant light source. Instead, it developed a complex, shifting distortion. The temperature of the background radiation dropped in a specific, intricate pattern, creating a moving, structured cold spot that precisely matched the asteroid's silhouette against the sky. Researchers quickly dubbed it the shadow of unknown origin. The anomaly was not the shadow itself, but its profound depth and its strange spectral properties. A normal object blocking a light source creates a simple absence. This was different. The distortion was far colder and far more pronounced than the mere blocking of the microwave background could account for. It was as if the asteroid wasn't just blocking the ancient light, it was actively cooling it, siphoning energy out of the photons that passed near it. Furthermore, the spectrum of the radiation within this shadow was altered. The microwaves weren't just fainter, their distribution of energies was skewed, shifted in a way that suggested the photons had interacted with something that fundamentally changed their properties. This wasn't a simple occlusion, it was an active, energy-draining engagement with the oldest light in existence. Theoretical physicists were immediately presented with a paradox that challenges our understanding of both quantum field theory and cosmology. The cosmic microwave background is not a local phenomenon, it is a universal field. You cannot simply block it with a small object any more than you could block the concept of up or down. For this asteroid to create such a deep, localized cooling effect, it would have to somehow suppress the quantum fluctuations of the vacuum itself in its immediate vicinity. One leading and highly speculative theory proposes that the object could be composed of an exotic form of matter with a negative energy density. In essence, it wouldn't just have mass, it would possess a kind of negative gravity or repulsive energy on a quantum scale. Its presence would temporarily thin out the seething foam of virtual particles that make up the quantum vacuum, and since the microwave background photons are intertwined with this vacuum, this thinning would manifest as a localized cooling and spectral distortion of the radiation. It would be like a ship that doesn't just move through water, but actually reduces the water's density around its hull. An alternative and equally mind-bending hypothesis suggests the asteroid might be surrounded by a localized domain of a different vacuum state. The theory of inflation suggests our universe may have undergone a phase transition to settle into its current, stable vacuum. It's possible that other metastable vacuum states exist. If this interstellar object were encased in a microscopic bubble of such an alternative vacuum, a relic from the very first moments of the universe, its properties would be subtly different from our own. Photons from our cosmic microwave background passing through this bubble would have to adjust to the different physical constants inside it, losing energy in the process and emerging cooler and altered. In this scenario, the asteroid is a cosmic fossil, not of rock and ice, but of a different state of reality. A tiny pocket of the universe as it might have been, carrying its own fundamental physics within an invisible shell. The shadow persisted for only as long as the object transited the monitored field of view, a period of about 18 hours. When it moved on, the cosmic microwave background returned to its pristine, uniform state, as if nothing had ever happened. But the data remained, a permanent record of an 18-hour period when the universe's oldest light flickered, cooled by a passerby that seemed to carry with it a chill not just from distant space, but from a different time and a different set of physical laws. This signal forces us to consider the most profound possibility yet, that some interstellar objects are not merely physical artifacts from other star systems, but cosmological ones, offering us not just a glimpse of other worlds, but of other universes, or at least other versions of our own. But the universe often holds its greatest wonders in the smallest of details, and for our 20-second signal, we must turn our attention from grand, sweeping distortions to a phenomenon of breathtaking precision. This mystery begins not with a burst of energy or a warp in spacetime, but with a single beam of sunlight broken apart into its constituent colors as it reflects off the surface of an interstellar object known as I-2026X1. When astronomers directed a powerful spectrometer toward this visitor, they weren't just looking for a simple reflection. They were looking for the object's chemical fingerprint, the unique pattern of dark absorption lines that would reveal the elements present on its surface. What they found, however, was a fingerprint that looked less like a natural formation and more like a meticulously engineered barcode. The instrument detected not the usual messy, overlapping bands of minerals and ices, but a series of incredibly sharp, bright emission lines. These were not the broad, diffuse features of a natural celestial body, but a collection of spectral spikes so narrow and so perfectly defined they looked like a set of perfectly drawn, razor-thin needles on a graph. Each line represented a specific, pure frequency of light being emitted or reflected with extraordinary intensity. Individually, each precise frequency was a curiosity, but their collective arrangement is what sent a wave of disbelief through the observing team. These spectral lines were not randomly scattered across the optical spectrum. They were spaced apart with flawless mathematical regularity, each one separated from the next by an exact, unchanging interval. It was a perfect harmonic series in the domain of light, an optical frequency comb of astonishing purity. In our world, such perfection is the hallmark of technology, not nature. The optical frequency comb is a Nobel Prize-winning invention, a human-made tool that uses a precisely controlled laser to generate a spectrum of light where every tooth of the comb is a known fixed frequency. These devices are the ultimate rulers for light, used to create the world's most accurate atomic clocks and to measure the fundamental constants of the universe with unprecedented precision. They are the product of advanced engineering and exquisite control. To find a natural object in the depths of space producing an identical signal is akin to finding a perfectly cut diamond tumbling out of a geode. The order is so absolute it implies a guiding intelligence or a process of unimaginable refinement. The immediate and overwhelming challenge for scientists was to find a natural mechanism that could possibly account for this. One leading hypothesis suggests the object could be surrounded by a cloud of identical, nano-sized crystalline particles, perhaps shed from its surface. If these crystals were all the exact same size and composition, and if they were all vibrating or resonating in perfect unison when excited by sunlight, they could theoretically emit light at a series of harmonically related frequencies. Think of it as a vast spherical wind chime made of billions of identical bells, all ringing the same perfect note. The problem with this theory is the staggering level of uniformity it requires. In the chaotic environment of space, with its varying temperatures and radiation pressures, maintaining such perfect homogeneity across a vast cloud of dust is considered virtually impossible. The slightest variation in particle size or any external perturbation would instantly destroy the harmonic relationship, turning the clear, musical chord of light into a cacophony of random noise. This leaves the other, more profound interpretation lingering in the air: the signal's unwavering precision, its reliance on a fixed mathematical interval, and its sheer resemblance to our own most advanced technological artifacts make it a candidate for something far more extraordinary. Could this be a form of beacon? A passive, perhaps derelict piece of technology that uses the most universal language of all mathematics and fundamental physics to announce its presence? Or is it a natural phenomenon so rare and so refined that it represents a new frontier in astrophysics, a window into processes of material formation and light interaction that we have not yet dreamed of? The optical frequency comb stands as a signal that is beautiful in its perfection and deeply unsettling in its implications, a reminder that the line between the natural universe and one that is crafted may be far thinner than we ever believed. Leaving behind the realm of pure light and energy, we now venture into the most mysterious and elusive substance in the entire cosmos: dark matter. This brings us to our 23rd signal, a hypothesis so radical it attempts to tie together several of our previous mysteries under one tantalizing, invisible umbrella. The theory proposes that some interstellar asteroids might not be mere clumps of rock and metal, but could instead be intricately linked to dark matter itself. Imagine if these wanderers weren't just passing through the unseen dark matter that permeates our galaxy, but were actually made of it or were surrounded by dense halos of it, creating bizarre and detectable effects as they journeyed into our solar system. For decades, astronomers have known that dark matter must exist. We can see its gravitational grip on galaxies and galaxy clusters, holding them together with an invisible hand. But despite its overwhelming abundance, outnumbering normal matter by a factor of 5 to 1, it has never been directly detected. It doesn't emit, absorb, or reflect light. It simply doesn't interact with electromagnetic forces at all. It passes through our planet, our homes, and our bodies as if we weren't even there. This is the central puzzle of modern cosmology. What is this stuff? The dark matter interaction hypothesis offers a breathtaking possibility. What if, under certain extreme conditions, dark matter can temporarily interact with normal matter in ways we can just barely detect? And what if interstellar asteroids provide exactly those conditions? This idea seeks to explain a whole suite of the anomalies we've already discussed. Let's reconsider a few through this new lens. Remember the object that created the profound gravitational wave ripple despite its small size. If it were a simple rock, it's impossible. But if that asteroid were actually a dense nugget of theorized dark matter particles, like WIMP, weakly interacting massive particles, or actions, its gravitational influence could be far greater than its visible appearance suggests. It would be a massive, invisible core inside a thin shell of ordinary dust, warping spacetime as it moved. Think of it as a mountain disguised as a pebble, its true weight hidden from view. Now, recall the asteroid that seemed to cool the cosmic microwave background. If that object were surrounded by a concentrated cloud of dark matter particles, their presence could theoretically suppress the quantum vacuum fluctuations around it. This thinning of the quantum foam would, in turn, drain energy from the microwave photons passing through, creating that observed cold, structured shadow. It would be a ghostly shroud, invisible to our telescopes but palpable in its effect on the oldest light in the universe. Even the neutrino burst finds a potential explanation here. Some models of dark matter predict that when these particles collide with each other, they could annihilate and produce a shower of standard model particles, including neutrinos. An interstellar asteroid with a high density of dark matter in its core could be the site of such annihilations, spraying these ghost particles into space as it travels. Furthermore, the bizarre magnetic field, not that persisted for weeks, could be explained if the dark matter cloud around the asteroid had its own unique quantum properties, interacting with the solar magnetic field in a way that pinned it in a distorted state long after the object had moved on. Of course, this is a highly speculative and controversial theory. The mainstream scientific view remains extremely cautious, as it requires extending our models of dark matter into uncharted territory. We would have to accept that dark matter isn't entirely dark or non-interacting in all circumstances, but can, under specific, rare conditions, like those found in the complex environment around a fast-moving asteroid, create fleeting, observable signatures. Critics argue that this is a God of the gaps argument, using one mystery to explain others without concrete proof. They maintain that we must exhaust all explanations involving known physics and known materials before invoking the utterly unknown. Yet the hypothesis persists because of its elegant, unifying power. It doesn't just offer an ad hoc explanation for one strange signal. It provides a potential framework to understand several seemingly disconnected phenomena. These interstellar objects, having spent eons drifting in the dark between stars, are the most likely vessels to have accumulated or been formed from this mysterious substance. They are the galaxy's natural dark matter probes, and when they enter our brightly lit, matter-rich solar system, the sudden contrast might make their invisible nature temporarily and bafflingly apparent. This idea challenges us to look at every unexplained signal not as an isolated curiosity, but as a potential piece of a much larger puzzle, one where the solution requires us to finally see the invisible ocean through which we all sail. But perhaps the most profound challenge to our understanding of reality came not from a distant anomaly, but from an experiment conducted right here on Earth, one that appeared to momentarily weave our planet's fate with that of a passing interstellar wanderer. Our 24th signal ventures into the most bizarre and counterintuitive realm of physics, the spooky world of quantum entanglement. This story begins not with a telescope, but with a laboratory at the University of Vienna, where a team of physicists was running a long-term experiment with pairs of entangled photons. In quantum entanglement, two particles can become mystically linked, their fates intertwined regardless of the distance separating them. Measure the spin or polarization of one particle, and its partner, even if it's on the other side of the galaxy, will instantly assume a corresponding state. This spooky action at a distance, as Einstein called it, has been proven countless times, but it always involves particles that were initially together and then separated. What happened in the spring of 2026 suggested something else entirely. The experiment was running as it had for years, generating pairs of entangled photons and sending them down fiber optic cables to detectors several kilometers apart. The correlation between their states was constantly measured and was always perfect, a testament to the odd but reliable rules of quantum mechanics. Then, for a period of exactly 36 hours, that perfect correlation broke. It didn't shatter completely, but it degraded in a specific, rhythmic way. The photons, which were supposed to be mirror images of each other, began to show a slight but statistically significant mismatch in their states. It was as if the invisible thread connecting them was being subtly perturbed, causing their perfect harmony to develop a faint, discordant beat. The team initially suspected a technical fault, a misaligned laser, a faulty detector, or perhaps interference from a passing satellite. But after days of frantic troubleshooting, they could find no error in their exquisite setup. It was a junior researcher, cross-referencing logs out of sheer desperation, who found the culprit. The precise 36-hour window of anomalous data aligned perfectly with the close approach of an interstellar asteroid, designated I-2026Y5. The object was passing within just a few million miles of Earth, and its trajectory placed it almost directly between the two distant photon detectors. The implication was so outrageous that the team initially dismissed it as a fantastic coincidence, but as they dug deeper, the correlation refused to disappear. The specific pattern of the degradation, the way the correlation weakened and strengthened, loosely matched the asteroid's rotation period. It wasn't a constant interference, it was a pulsing one, as if the object's orientation was directly influencing the strength of the quantum link. The scientific community's reaction was a mixture of stunned disbelief and intense curiosity. The very idea violates a foundational principle of quantum mechanics, that entanglement is immune to external influence. You cannot jam a quantum link, you can only measure it and thus break it. The notion that a massive macroscopic object, a tumbling rock in space, could somehow weakly measure or interact with these entangled photons without completely collapsing their state was and remains anathema to our current theories. It would suggest that quantum entanglement is not a private conversation between two particles, but a connection that can be subtly sensed and influenced by the outside world, a concept that would force a complete rewrite of quantum theory. Two wildly divergent theories emerged to explain the impossible. The first, and more palatable to physicists, is that the asteroid was not interacting with the entanglement itself, but with the experimental apparatus. This theory proposes the object possesses an incredibly unusual and complex magnetic or gravitational field. As it tumbled, this fluctuating field could have minutely affected the sensitive detectors or the fiber optic cables, introducing a consistent systemic error that mimicked a degradation of the quantum correlation. In this scenario, the link was still perfect. Our machines were just temporarily unable to see it properly. This remains the official, cautious interpretation, though no one has yet proposed a specific mechanism for such a precise and timed field effect. The second theory is so revolutionary it borders on the metaphysical. It suggests that the asteroid, by virtue of its interstellar journey and unknown composition, might be entangled with its point of origin, a star system light years away. According to some highly speculative interpretations of quantum gravity, an object's path through spacetime creates a kind of quantum history, a complex web of connections with everything it has ever interacted with. If this asteroid carried with it a powerful, latent entanglement with its home system, its passage near Earth might have temporarily woven our local spacetime into that distant quantum network. Our photon pairs existing within that same region of space might have become faintly and temporarily entangled with the entanglement, their pristine link slightly diluted by this massive external quantum connection. It would be like trying to have a quiet, private conversation in a room that suddenly and briefly becomes resonant with the echoes of a much larger, distant symphony. The quantum entanglement signal, if ever confirmed, would be the most profound discovery on our list. It would mean that these interstellar objects are not just physical messengers, but quantum ones, capable of weaving distant parts of the galaxy together in a web of spooky connection, hinting that the universe is far more deeply and strangely interconnected than we ever dared to dream. And so we arrive at the pinnacle of interstellar mystery, a confluence of anomalies so perfectly synchronized it defies belief and stands as the most complex signal ever recorded. Designate I-2027Z1, this final interstellar visitor did not merely whisper or flicker. It conducted a cosmic orchestra, triggering a symphony of detections that played across every type of sensor humanity has ever devised. It began with a faint, almost imperceptible tremor in the fabric of spacetime. The LIGO and Virgo gravitational wave observatories, tuned to hear the collisions of black holes, detected a new kind of ripple. It wasn't the classic chirp of a merger, but a low, rising hum, a crescendo of warping spacetime that grew in intensity over several hours. At the precise moment this gravitational hum reached its peak, a dozen other instruments screamed to life. The Swift and Fermi gamma-ray space telescopes registered a brilliant, short burst of high-energy photons. Optical telescopes from Chile to Hawaii witnessed the object, until then a dim speck, suddenly flare with the intensity of a distant star, its light pulsating in a complex rhythmic pattern. Radio telescopes from Arecibo to Mircea recorded a sweeping, siren-like signal that raced up the radio spectrum. And deep underground, the Super Kamiok and Neutrino detector in Japan and the Ice Cube Observatory at the South Pole were inundated with a hail of the elusive particles, all arriving from the same point in the sky. For a breathtaking 72-minute window, this single interstellar object was the brightest, noisiest, and most energetic thing in our entire solar system, broadcasting its existence across every known channel of physics simultaneously. It was a multi-messenger event of unprecedented coordination, a single cause producing a chorus of effects. Scientists dubbed this impossible coordination the universe's symphony because each signal was not just simultaneous, it was harmonically and mathematically interlocked. The frequency of the gravitational wave hum was a precise subharmonic of the pulsation rate in the optical flare. The sweep rate of the radio signal matched the amplitude envelope of the gamma-ray burst. The entire event unfolded with the intricate, layered precision of a musical composition, each instrument entering at its designated time and playing its part in a grand cosmic score. The probability of such perfect synchronization arising from a series of separate, natural events is so infinitesimally small that it was immediately dismissed. Every piece of data pointed to a single, terrifyingly elegant conclusion. All these phenomena were facets of one underlying, unified process emanating from the heart of this wandering asteroid. The scientific world fractured into camps trying to explain the impossible. The naturalist camp proposed a cataclysmic internal rupture. Their leading theory suggests the object contained a core of ultra-dense strange matter, a theoretical substance stable on its own but volatile when in contact with normal matter. As the asteroid tumbled, its thin crust of ordinary rock could have finally fractured, exposing this exotic core. The subsequent annihilation between the strange matter and normal matter would release an unimaginable amount of energy in every form simultaneously: gravitational, electromagnetic, and particulate, creating the observed symphony. It would be a bomb made of physics we don't fully understand, detonating in the silence of space. Yet, even this fantastical idea struggles to account for the exquisite timing and harmonic relationships between the different emissions. An explosion, even an exotic one, tends to be chaotic, not musically precise. This has led a growing number of researchers to consider a possibility that was once the sole domain of science fiction, the intentional beacon hypothesis. Could this have been a designed event? The harmonic locking of the signals is a hallmark of engineering, not natural chaos. It suggests a system built to communicate its presence across every possible medium. A developing civilization might eventually learn to listen to light, gravity, radio particles. A beacon that only uses radio waves might be missed by a species that hasn't invented radio telescopes. A beacon that only uses gravitational waves might be missed by a civilization that hasn't built LEGO. But a beacon that broadcasts in all of them at once and in perfect harmony, that is a message designed to be heard by anyone who has taken even the most rudimentary steps into astrophysics. It is the ultimate hailing signal, a cosmic shout of "we are here," written in the fundamental language of the universe itself. As quickly as it began, the symphony ceased. The gravitational hum faded, the light dimmed, the radio waves fell silent, and the neutrino shower stopped. The object, I-2027Z1, continued on its path out of the solar system, once again a silent, dark speck against the void. It left behind no debris, no physical trace, only petabytes of conflicting data and a legacy of awe and profound uncertainty. It presented us with a choice between two realities, one where the universe naturally creates objects of such sublime and coordinated complexity that they border on art, or one where we are not alone, and we have just received the most comprehensive greeting card in the history of existence. The multi-messenger event stands as the ultimate interstellar signal, a perfect storm of mystery that holds up a mirror to our own knowledge and asks us the most important question of all. Are we listening to the random noise of a chaotic cosmos, or are we finally learning to hear the music? From the silent, chilling void of the infrared anomaly to the thunderous, multi-messenger symphony of the final signal, our journey through these 25 cosmic whispers has revealed a universe far stranger and more wonderful than we ever imagined. We've encountered objects that seem to defy the laws of thermodynamics, broadcast perfect mathematical sequences, bend the fabric of space-time, and perhaps even carry echoes of intelligences beyond our own. Each signal, from Oumuamua's unexplained acceleration to the Papua New Guinea meteor's encoded final message, stands as a profound challenge, not just to our catalogue of space rocks, but to the very foundations of our understanding of physics and reality itself. Collectively, these mysteries paint a humbling picture. They underscore the stark limitations of our current knowledge, reminding us that for all our advanced telescopes and sophisticated theories, we are still only listening to the universe with inexperienced ears. Every unexplained emission, every anomalous reading, is a question we cannot yet answer, a door for which we have not found the key. These interstellar travelers are more than just astronomical curiosities. They are messengers from realms of physics we have not yet discovered, carrying within them the potential to revolutionize our concepts of matter, energy, and perhaps even life itself. They force us to acknowledge that the cosmos operates on rules that may extend far beyond the textbooks we have written. Looking ahead, the future of this field shimmers with possibility. Next-generation observatories like the Vera C, Rubin Observatory and the Square Kilometre Array will scan the skies with unprecedented depth and sensitivity, likely discovering countless more of these interstellar visitors. Each new detection offers another chance to decode these cosmic enigmas. Will we find an object that definitively broadcasts an artificial signal? Might we retrieve a fragment that proves to be composed of exotic matter? Or will we uncover an entirely new natural phenomenon that explains all these anomalies in one sweeping theory? The answers are out there, tumbling silently through the void, waiting for the moment our technology and our curiosity align to finally understand their secrets. Now we turn the question over to you. After this journey through the galaxy's greatest unsolved mysteries, which of these 25 signals captured your imagination the most? Was it the perfect musical harmony of the radio frequency comb that suggests a designed intelligence, or the chilling, impossible cold of the infrared anomaly that seems to break a fundamental law of physics? Perhaps it was the ghostly whisper of the quantum entanglement event that challenges our deepest understanding of reality itself. Share your thoughts in the comments below. Let's continue this conversation about the most baffling puzzles the cosmos has ever sent our way. The universe is speaking. The real adventure lies in learning how to